Assalamu alaikum wa rahmatullahi wa barakatuh. Hi all. Our group is group 1. We would like to make a video presentation of our topic given from our doctor of entitled by Biosensor Development for Detection of COVID-19. This is my group teammate members, me and my teammate who will present also, he will present part 2. Biosensors have become a promising tool for the rapid and sensitive detection for the harmful viruses such as SARS-CoV-2. This is an overview of the recent advances in biosensor technology for the detection of COVID-19. The presentation will highlight various types of biosensors. The presentation also highlights the need for the further research and development in this field to achieve more sensitive, specific, and low-cost biosensors of SARS-CoV-2 detection which can have impact on public health. SARS-CoV-2 has a roughly spherical shape like a tiny ball. Its most distinctive feature is the crown of spikes, which are protein. They give the virus its characteristic corona appearance and play in a crucial role on its ability to infect human cells. Over time, SARS-CoV-2 can mutate, leading to new variants with slightly different shapes and properties in determining the SARS-CoV-2 virus. The single most common mutation for COVID-19. That's why research and development of the biosensor selective of SARS-CoV-2 is necessary. Here I would like to make some presentation of the available detection of COVID-19, its working principle, and the fabrication process. So, working principle, a simple handheld, highly sensitive miniaturized biosensor modified with a human receptor called angiotensin converting enzyme 2. It can detect the SARS-CoV-2 using 10 milliliter sample within 4 minutes through increased resistance to charge transfer of a redox probe measured by electrochemical impedance spectroscopy. So, different authors proposed in an article new method of detecting SARS-CoV-2 that involves using this enzyme ACE2 in a short form. So, it transforms biochemical information from a specific molecular binding event between the SARS-CoV-2 spike protein and ACE2 enzyme into electrical signal that can easily be detected. The electrochemical change is then detectable by monitoring charge transfer resistance RCT. The diameter of the arc of nucleus plot, which correlates the number, they correlate the number of target bound to a receptive surface. The fabrication. If we see the fabrication process, number one, we do cutting paper pieces into shape of working electrodes. Then we print a layer of a carbon ink into a paper pieces. Zinc oxide will be used for the carbon ink. Then we immobilize, probe and block molecules to the surface of working electrode. Then eventually we use working electrode to capture the target molecules for electroscopy by sensing. As we see that our system will use enzyme immobilization, we can ask ourselves what is the advantage and disadvantage of this. So the advantage is that enzyme immobilization, the system is high sensitive, the selectivity is high also, and also there will be a continued monitoring whatever time you can test it different times for the for the analyte. So the system will detect the analyte in every time we want. Also, there is a disadvantage or drawbacks of the system. Sometimes the enzyme stop suddenly. Also, there is a diffusion limitation between the target and the enzyme, because as we know, enzyme we enclose in the surface. So sometimes there is limitation. Also, there is a complexity of the system. Thank you. I would like to hand over to my teammate to present part 2.
Now, I will talk about the biomarker detection. From the picture shown, there's a COVID-19 diagnostic test through the RT-qPCR. It is used to detect the viral RNA in which the RNA is reverse DNA is amplified and in QRT-PCR will be quantified. Next, I will talk about nucleic acid-based biosensor. Loop-mediated isothermal amplification, the short form is called LAMP. It is developed by Notomo. It works by amplification of samples at a fixed temperature through cycles of two types of elongation reactions. It requires only a single enzyme to be used at a constant temperature throughout the reaction, reducing the cost of this method and possibly allowing the development of a portable detection method. 4 to 6 primers are used and they bind to specific genoregions. This gives LAMP its high specificity compared to other detection methods. Next is the biosensor for the detection of antigens proteins. Immunoassays can diagnose the antigens in less than 1 hour. To identify a biological molecule, the target molecule binds to the biosensor. The transducer with embedded nanostructure turns the detection into electrical signal by the detector. Since the target protein in affinity sensor is detected on device surface, the creation of such sensors requires the development of a surface with right protein recognition capability, such as molecularly imprinted polymers. Next, I will talk about the fabrication of biosensors. From the research investigated, I found some of the fabrication of biosensors to diagnose the COVID-19. First is printing and cutting, molding, and also photolithography. First, I will talk about printing and cutting process. Print the design pattern onto a suitable paper substrate. Common choices include filter paper, nitrocellulose, or chromatographic paper. Use a printing technique appropriate for the application such as inkjet printing or screen printing. It includes any necessary function elements such as hydrophobic barriers or reagent zones in the printing process. For cutting, it uses cutting tool, for example, laser cutter or precision blade, used to cut the paper into the desired shape and size of the final device. And it defines the device geometry, including the location of channels, wells, and other features during the cutting process. For the modification, it assembles the different layers of the paper-based device if it involves multiple layers. It aligns and stacks the layers to form the complete device to ensure proper registration of features. If additional structure is potential recycling of non-degradable biosensors. Okay, what is the challenge faced for the diagnosis COVID-19? First is low accuracy. Current conventional methods face issues of low accuracy, especially in antibody-based immunosensor, leading to false positive and false negative results. Second is complications in sample preparation, particularly in nucleic acid-based detection techniques. It involves intensive laboratory resources, high cost, and long processing times. Third is time delays in immune response and detection. The time required for the development of detectable antibodies and viral loads poses a challenge in antibody-based detection methods, potentially leading to delays in diagnosis. Last is environmental concerns. While most biosensors are made of biodegradable and environmentally friendly materials, the environmental impact of non-degradable biosensors need to be considered. In conclusion, an immediate identification of COVID-19 is essential to stop the illness from spreading. Traditional biochemical and serology tests have numerous limitations. Molecular approach demands a significant amount of sample processing time and expensive specialized infrastructure. Although serological diagnostics do not have this limitation, their capacity to diagnose COVID-19 is limited and their sensitivity is lower. Biosensors hold the potential to provide a modern, simple, lightweight, precise, and highly sensitive substitute for the costly and complex methods they are now in use. Thank you so much.